Hey class, what's going on today? Just wanted to have a brief discussion on just the basics of ultrasonic sensors. So I've got this page pulled up here. I got Carnegie Mellon University just had this on, and I just grabbed this as a reference. A lot of basic information on this page. Um, so we'll just kind of break down ultrasonic sensors just for a couple of minutes, just so you can get a background understanding. I'm sure most of you have a pretty good understanding of what they are and how they function. But again, just a refresher, just a review. So ultrasonic sensors operate on the principle of ultrasound. So much like checking on a fetus in the womb, the ultrasonic sensors, it's the same principle. Okay, so there's various applications, medical industry, robotics, vehicles, but as far as like the sensor, how it's built itself, it actually has piezoelectric crystals inside the sensors, and basically they grow and shrink when electricity is applied and removed. So at a certain frequency, we pulse these sensors, it sends out waves, and then these waves will contact objects, whatever they'll contact, and then they'll bounce that wave back to the sensor. So the ultrasonic sensor is both a sensor, or it's sending and receiving these ultrasonics or ultrasound waves. So just so you guys know, or for your information, Saab, may it rest in peace, started using ultrasonic sensors in 2002. And basically this was primarily when the gear shifter was moved to reverse, power was applied to these sensors, and it was just primarily for proximity. Again, this was before backup cameras, but the effective range on these older sensors was 10 feet at the max. Sensor technology has improved vastly, and also the processing and computing power. So the new sensors on vehicles are 2 or 3 times that distance. But anyway, just so you guys know a little bit more about Saab, I know you're all craving to learn everything you can, right? But I'm just joking a little bit. Another thing that you'll notice, there's generally multiple sensors, 4 on a back bumper, 4 on a front bumper, generally some on the side as well. The reason that we use multiple sensors is to increase object awareness and kind of mitigate the if we do encounter an odd-shaped object. Like if you guys have seen the bottom of a pop can or a soda can, how it's that concave design. If you were to stick that, in fairly close proximity to an ultrasonic sensor and kind of move it around, the likelihood of those sound waves, those ultrasound waves, bouncing off and kind of bouncing to a different direction and not bouncing back to the sensor is fairly likely. So like I said, there are some limitations, but we use multiple sensors to kind of mitigate that. There's also another thing called the Doppler effect or the Doppler shift, and that's basically to when the sensor the sound waves bounce off a moving object. So there's a couple ways that you can calculate proximity to objects. Most of the time you can count, or there's the little formula here. Okay, so again, the speed of the sound is right here, about 1130 feet per second, and then you times it by the amount of time taken. Again, or you can divide by 2, and that gives you your distance. So that's one way to calculate it. Another way is to look at the frequency of the sound wave as it's bounced back or projected back to the source. This is kind of how the Doppler shift works. So you can calculate proximity by measuring the return time, or the frequency of the returning wave, or a combination of both. So anyway, there's just kind of a basic refresher on ultrasonic sensors. Hope this was helpful to you, and we'll talk to you soon.